Now, that means that all of the other elements in the periodic table have the potential to be reactive because their outermost level is not fully occupied by electrons. So they have the potential energy to bind with other elements. They have this tendency to either gain electrons from another element or give up or lose their electron because that outer layer or outer shell is not in its content 8 happy place. And so they are more likely to be reactive and form bonds with other atoms. So here are some examples. Hydrogen, of course, is always ready to react because he only has one electron in his outer shell, and he would be so happy to have a second electron. So he can get that by making a bond with another atom. Carbon has a total of 4 on its outer shell, so it would be really happy if it had 4 more electrons on its outer shell. Oxygen only has 6. Oxygen would be happy if there was 2. Hence, if you think about it, we have water, which is H2O. Hydrogen has the 1 electron. He can share it and bond, same here, with oxygen. And so you get, that's how it's so easy for us to get 2 hydrogens bound to an oxygen to give us H2O, because they're sharing electrons, all right? So they're going to make bonds by sharing these electrons. Another reactive element, and if you'll notice, is all of these elements here are our most common molecules in our body that we talked about earlier in this lecture in this chapter, in terms of which molecules are most common in the body. Because here we are with sodium. So we have sodium, carbon, oxygen, hydrogen, main players in our makeup. So sodium has 11 electrons. And what's interesting about sodium is it's got 2 in its inner shell. It's got, sorry, that was supposed to be a check mark. It's got 8 in its second shell. And then that makes 10, but then it's got this 1 lone electron, right? Here he is. He would be a lot happier if he had 7 more electrons. He's got this 1 lone electron kind of floating out there. So he's always happy to make an agreement with someone and make a bond. So what are these bonds that can help these atoms hold together and make substances or molecules, more complex molecules and compounds? You can have 3 main types of chemical bonds. We're going to talk about each one in turn because each one has different characteristics. There's an ionic chemical bond. This is where electrons are actually exchanged between atoms. Okay, so in this case of sodium, he may actually give away that electron to another molecule, and in doing so will form an ionic bond. A covalent bond is when 2 atoms will share electrons. So a great example of a covalent bond would be water, because you've got these hydrogens that are sharing an electron with oxygen. And then there are hydrogen bonds, which, yes, we just talked about hydrogen here in water, but this is a little bit different. Hydrogen bonds are going to be attractions between molecules and actually lead to a lot of the bonding that occurs in compounds. Okay, so these are due to these charges on atoms. So let's look at each one in turn. Ionic bonds are going to involve ions, or the formation of ions. And what are ions? Ions are going to be atoms that have given away or taken in an electron in their outer shell. And when they do that, electrons carry a charge with them. They carry a negative charge. And so by giving away an electron, you're giving away a negative charge. By taking on an electron, you're taking on a negative charge. And so in either case, in an element or an atom that has normally the same number of protons as electrons, when you change that number of electrons, you end up with a net charge of that atom, and then we call it an ion. Anions is the name we give to an atom that has gained an electron, right? So it's gained 1 or more electrons, so it becomes more negative. A cation is carrying a positive charge. And that's because it has given away or lost one or more electrons. And so there's more positive charge there. It's lost some of its negative charge. And if you remember, opposites attract. That's usually just a common little theme that we say in life and society, but actually this comes from as well in chemistry. The opposite charges attract each other. Positive likes negative and negative likes positive. And because you develop these ions when you give away or take in an extra electron and you generate a charge, then these charges will be attracted to opposite charges of other elements. And that's going to give an ionic bond. So they're formed by transferring or moving or exchanging valence shell electrons between the atoms. It's very important that you realize these guys are not sharing electrons. They are literally giving them away. So our prime example, remember sodium, he's got this one lone electron here in his valence shell. And so it's pretty reactive. It's ready to react with someone else because he's all by himself out there on the outer realm. Well, chlorine happens to have 7 electrons on its outer shell. 2, 4, 6, 7. So chlorine would be really happy if it could fill its valence shell with another electron. And so what happens then is sodium will say, well, I can give you one because this guy's all by himself. And by giving it away to chlorine, then sodium itself becomes positive because it lost a negative electron. And so this becomes a cation. That other electron went over here to chlorine and became a chloride. This is when we go to chloride, became a chloride ion. So chloride or chlorine got this extra electron, gained some negative charge, and became an anion. Now, when these two elements or atoms are in this state, when they have been turned into an anion and a cation, the attraction between their resulting charges is so great that they hang out together. They're so attracted to each other, they don't want to leave each other's side. All right. So it's kind of like a relationship. All right. It's like, oh my gosh, I'm so enamored with you. I gave you something and I'm just like even charged about it. And so they're so enamored that they form what you could say is an invisible bond. It's just that it's so strong, they're going to hang out and they're going to form what we call sodium chloride, or what you may know as common table salt. When a ionic bond is formed, they, depending on what the ionic bond is formed between, depending on the atoms, it can form crystals instead of molecules. And we see this even in your common table salt, all right? So because their charges of becoming an anion and cation are so strong, then they start to cluster together. So you may have a sodium here, right? And he's going to be a cation because he's got this positive charge. Well, he's so radiant with this positive charge that he's not just going to form this bond with this one chlorine negative anion or chloride negative anion. He's going to also attract these other ones, and because they also have turned into anions, right? And so there's this attraction that results in all of these ions sticking together. And so all the ionic bonds clump together and you get crystal formation. And that's why table salt is the way it is, or salt in general.